Around IT in 256 seconds by Tomasz Nurkiewicz. Episode 34. SQL joins.
In relational databases, data is kept in relations, commonly known as tables. Simplifying, when data is normalized, it's not duplicated. For example, when storing books and authors, you don't keep an author's name next to a book record. Instead, you use a so-called foreign key that references the author in another table. Thanks to this level of indirection, books by the same author do not store repeated information. This has many benefits and one huge drawback. In order to look up a book together with a corresponding author, you must somehow correlate these two tables. This is called joining. You can think of joining as taking all records from one table and finding a corresponding record in another table. Typically, one column in one table must be equal to another column in the other table. In our example, Books table has an author ID column. That column must reference an existing record in the other table. Typically, it's a primary key, like author.id. Thinking imperatively, for each book, the SQL engine must find an author for a given author ID. In SQL terms, it's called inner join. It's written as select star from books join authors on books.authorID equals authors.id. Or simply select star from books, authors, where books.authorID equals authors.id. Now, there are some edge cases. What if there's a book with no author at all? For example, the excellent Frankenstein novel was first published anonymously. In our database, the author ID is null. Inner join can't find a corresponding author for Frankenstein, so this book is entirely skipped. This is where outer joins start to appear. Replace join with left join and you'll see all books in the results. Some of them, like Frankenstein, will have null, where author's ID and name were expected. In the same manner, you can try right join. In that case, you'll end up with authors that never published any book. Put differently, records in the authors table that are not referenced by any record in the books table. Another interesting side effect: if an author never published any novel, he or she will appear once. The same applies for authors that published just one novel. But what about authors who published more than one book? Well, they will appear as many times as many books they've written. Each and every row from one table is mapped to each and every row of another table. This is especially useful combined with another technique: self-joins. You can join a table with itself. For example, imagine you are looking for pairs of books published the same year. A book table has a published year column, but how do you find two books with the same published year? Simple. Join every book with every other book first. Just be careful. For a tiny library of 100 books, this produces 10,000 pairs. So an extra filtering condition is needed to only choose pairs with the same year. For example, select star from books B1, join books B2 on B1 published year equals B2 published year, and aliases B1 and B2 are needed to distinguish between books tables. Implementing fast joins requires quite a lot of engineering and optimizations, but that's a different story. That's it. Thanks for listening. Bye.